Hi everyone, welcome back to the channel. This problem is from a book called Irodov, which I think you might already be knowing about it. I have selected this problem because I wanted to explain few concepts here and also to showcase you how to solve this problem properly. I've seen that many students and many teachers, in fact many other solution books also have provided answer or solution which is not exactly correct. They only work under certain assumption and they do not mention those assumptions as well. So I'll show you two ways to solve this problem. First is the way usually people solve, but the second one is the right approach, which will also give you the assumptions under which the solution one, which is a typical solution that exists. Okay, so let's just get into the problem. So here we have two equally charged spheres. So let's say the charges are Q, okay, and mass M, and are suspended from a point, let's say O, by a silk threads of length L. So this length is L. And the distance between the spheres is x. Okay, so let's say this distance is x. Okay, and it is also given that this is very less compared to the length of the string or the thread. Find the rate at which the charge leaks off if their approach varies as the given equation. So the first question is, why would you think charge should leak off here in this case? Okay, so the first question, why should charge leak off? Okay, can you answer this question? Think about it. Okay, so charge should leak off because they are giving a approach velocity v equal to a divided by root x, right? So if let's say charge is constant, then it will always be in the equilibrium position. It will not move. But since it is moving and it is following certain equation for velocity, so which means that the forces are changing. And here the gravity is constant, the tension in the string would be constant, weight will be constant. So only the electrostatic force that we have should change. And why would they change? So the only thing that can change here is the Q, because the electrostatic force is 1 by 4 pi epsilon naught Q square by x square. So unless this changes, there would not be any approach velocity, right? You see that? Okay. So the charges must leak off. Okay. The other option could be, instead of approach, they are separating, which means that some charges are getting added. That could also be a scenario. Okay. But whatever might be the case, if there is a relative velocity between these two masses, then the forces must be there. Okay. Now let's try to solve the problem. Okay. So let's assume that the tension is T in the string, and let's take this angle as theta, okay, which is a vertical line here. Okay. The weight is mg, and let's say the electrostatic force is Fe. A, B, and C. So from triangle OAC, sin theta as x by 2 L. Sin theta will be x by 2L. Okay, so I hope this is clear. Okay, now this is very small. That would mean sin theta equal to theta as x by 2L. Okay, so with this, let's write the equation for the equilibrium. Okay, now what I'm saying is that this only works in certain condition, which I will show you in what condition this should be true. But let's assume that we have equilibrium. If you take this direction as x and y, the vertical direction is y. So we have Fe minus t sine theta equal to 0. Although I just want to point out, only true with certain assumption. Okay. So Fe is 1 by 4 pi epsilon naught q square by x square equal to t sine theta. And in the y direction, this is fx is 0. And then if you take fy as 0, then t cos theta is mg. Therefore, we get 1 by 4 pi epsilon naught q square by x square mg tan theta, which is equal to mg theta, which is equal to mg x by 2l, because theta is x by 2l, right? Okay. Then we can write q square is equal to 4 pi epsilon naught mg x cube by 2l. And let's simplify this. 2 pi epsilon naught mg by l x cube, and let's take it as kx cube, where k is 2 pi epsilon naught mg by l. Okay. Now let's just differentiate this equation with respect to time, because we need dq by dt, right? So the question is, what is dq by dt? So this is 2q dq by dt equal to 3kx square and dx by dt. Don't forget to add dx by dt here. And this is 3kx square. And what is dx by dt? It is given here as a by root x. V equal to dx by dt as a by root x, right? Okay. Therefore, dq by dt will be 3k a x 3 by 2 by 2q. Okay, so which is 3k a x 3 by 2 by 2. What is q? So q is nothing but q square is kx to the power 3. So this is root k and x to the power 3 by 2. Therefore, this cancel out, and dq by dt is simply 3 by 2 a root k. Okay, which is 3 by 2 a 2 pi epsilon naught mg by L. Okay, so this is the expression for dq by dt. Okay, now let's solve this problem in a proper manner. So this is the typical solution that many teachers also give, but this is not exactly correct. Okay, although the answer is correct, but it is under certain assumption. So check this. The given is velocity of approach, which is a by root x. Now this is a function of x, and it is also dx by dt, a by root x. So what is d2x by dt square? This will be minus half a x minus 3 by 2 and dx by dt. Therefore, d2x by dt square is minus 1 by 2 a x minus 3 by 2, and dx by dt is nothing but a by root x. So this is minus a square and by 2x square. So this is the acceleration. So when we consider equilibrium, we take acceleration as 0, right? But the function that the question is giving is v varying with respect to x. Therefore, acceleration is non-zero. So here if you see, the acceleration is non-zero, which means the equilibrium is not possible. The spheres will start moving, okay, the moment charge is leaking off. Therefore, we need to change the equation. So now we need to take fx is equal to max, okay, and this will be mx double dot, which is the acceleration of the sphere. So let's take sphere acceleration equal to minus t sine theta plus fe. Okay, so you can check this. This is t and this is fe. Now, what is the distance between two sphere? The distance between two sphere is x. So the each one is approaching with x. They have to cover x by 2. Therefore, the x sphere is x by 2, and therefore x double dot sphere is also x double dot by 2. Okay, so we can replace this with mx double dot by 2 equal to minus t sine theta plus 1 by 4 pi epsilon naught q square by x square. Okay, and then we know that fy is 0, which is t cos theta is mg. Therefore, t sine theta is mg tan theta, which is mg theta, which is mg x by 2l, right? We computed that. So now if you plug that into the equation, so it becomes mx double dot by 2 equal to minus mg x by 2l plus 1 by 4 pi epsilon naught q square by x square. Okay, so now it continues with simplification. Mx double dot equal to minus mg x by l plus 1 by 2 pi epsilon naught q square by x square. And what is mx double dot? So mx double dot is nothing but minus ma square by 2x square. Remember, we computed it. A square by 2x square, which is x double dot. Okay. Okay. So then, therefore, we can write minus ma square by 2 equal to minus mg x q by l plus q square by 2 pi epsilon naught, and hence we can write q square by 2 pi epsilon naught equal to mg x cube by l minus ma square by 2. Okay, and then we have q square as 2 pi epsilon naught m g x cube by l minus a square by 2. Okay, and if you differentiate this, so we get 2q dq by dt equal to 2 pi epsilon naught m and g 3x square by l into dx by dt. We should never forget this. Okay, and then the other part is 0 because this is constant. Okay, so now we have dq by dt equal to 3 pi epsilon naught mg by l cube x 3 by 2. Okay, and we should also write a. Okay, so this is the expression for dq by dt. Okay, and hence now we plug in the q also here. So q is right here, so we can just take this and put it here. So this will become 3 pi epsilon naught mg a x 3 by 2 divided by L root under 2 pi epsilon naught m gxq by L minus a square by 2. Okay, with little bit of simplification, we can get 3 by 2 a 2 pi epsilon naught mg by L, and here we get x 3 by 2 divided by x3 minus LA square by 2g, and this is 1 by 2. Okay, now when the x cube is much greater than LA square by 2g, then x cube minus LA square by 2g is equal to x cube. Okay, so the condition is x has to be really greater than LA square by 2g 1 by 3. Okay, this is the condition. Now there is a paradox here. If you see, the question said that L is greater than x. Okay, which means that this component L is greater than x, but eventually x is greater than a. So which means that a must be very small. Okay, so when the approach velocity is a by root x, if x is small, v is high, but v is slow here. It's given, if you see the question, v has to be relatively very small, which means that a is small. So this is correct assumption. So only under this assumption, if we assume this one, then if we go back and to this equation, then dq by dt is 3 by 2 a 2 pi epsilon naught mg by L, which is also equal to the dq by dt which we got from the equilibrium condition. But that is only true when we have this satisfied. Otherwise, the equilibrium approach is wrong. Okay, if a is not small enough, then we won't get the right equation of dq by dt using equilibrium approach, because there would be enough velocity and enough acceleration there. Please do send me your feedback and your comments. Any question if you might have, feel free to just send me directly on my email ID, or you can leave a comment. Please subscribe and like the video. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.